All right, let's get right into it. We're going to pull back the curtain on a field that's, well, it's pretty misunderstood, but it's also one of the most essential on the entire planet. I'm talking about electrical and electronics engineering.
So what do you picture when you think of these engineers? Just connecting a few cables? Or is it something a whole lot bigger? Like, are they secretly running the world behind the scenes? Well, the answer, that's probably going to surprise you.
See, behind everything you do, every single day, at home, in giant factories, even behind the AI you hear so much about, there's this kind of invisible hand making it all work. And yeah, that hand belongs to an electrical and electronics engineer. Just think about your morning. Right from the moment you wake up. That alarm on your phone, an engineer designed the circuits. Your smart coffee maker that gets your caffeine fix ready, an engineer programmed its little brain. And the GPS in your car, even the traffic lights that hopefully turn green for you. Yep, you know who to thank. And that's just your morning. This field is so fundamental, it's at the heart of everything from life-saving surgical robots to the self-driving cars we're all waiting for. It's not just some job, It's really the engine of modern innovation. And get this, right now it's one of the most needed fields in the world.
Okay, so we've seen how it impacts your personal life. But now, let's zoom out. Let's step inside a modern factory, the world of massive scale industry. Because this is where things get really, really cool.
If you were to walk into a modern factory today, it might seem empty. Not a lot of people around, but things are happening. Production is humming along 24/7. That's automation in action. It's like this magic that lets incredibly complex stuff happen flawlessly without a person needing to be there every second.
So how does it all work? What's in charge?
Well, it's a little box called a PLC, a programmable logic controller. The best way to think about it is, it's the factory's brain. It's the central command, conducting this entire orchestra of machines, telling every single one what to do, when to do it, and exactly how.
And, if the PLC is the brain, then every brain needs senses, right? That's where sensors come in. They are the factory's eyes and ears. They're constantly feeding info back to that PLC brain, measuring temperature, checking speeds, monitoring pressure, everything. It's how the whole system sees and feels what's going on, so it can react.
And don't think this is some small niche thing. We're talking about massive global companies. You've heard of them: Siemens, ABB, Bosch. These giants hire tens of thousands of these engineers just to design, build, and maintain these incredibly complex systems all across the globe.
All right, so we've seen the huge industrial scale. Now let's zoom all the way back in. Let's focus on something much, much smaller, but honestly, just as complex. The tech you're probably holding in your hand right now.
Just take a second to really look at your smartphone. It's an absolute miracle of engineering, isn't it? Inside that thin little case, an electrical and electronics engineer designed the processor, the memory chips, the antenna system that lets you make calls, the tiny circuit that stops your battery from overheating, even the drivers that make your screen light up. It is a complete, powerful system that fits in your pocket.
And it's not just your phone, is it? The whole idea of a smart home is basically a playground for these engineers. Your voice-activated lights, the security camera you can check from anywhere, the thermostat that learns when you're home, all of that stuff is running on tiny embedded systems, Wi-Fi, Bluetooth, all designed by an electrical and electronics engineer. Okay, let's look to the future now, because this is where we hit the absolute cutting edge. And the thing is, electrical and electronics engineering isn't just keeping up with the future. It's literally building the physical hardware that the future runs on. This is what's so cool. This field is the bridge between software and the real world. Think about it. When you use something like ChatGPT, you're not just talking to the cloud, you're talking to massive servers packed with special processors, GPUs and TPUs that were designed by EEEs to handle that insane workload. Or look at Tesla's autopilot. That's a huge hardware challenge, making radar, LiDAR, and cameras all work together perfectly. That's an EEE's job. Drones, they're basically flying robots, and it's the flight controllers and communication systems inside that make them work. And the impact gets even more profound. We're talking about medicine. These engineers are literally saving lives. They design the incredibly complex electronics inside MRI machines that let us see inside the human body. They build the EKG monitors that watch over a patient's heart. They create the robotic systems that allow surgeons to perform miracles. It's incredible.
All right, so now that we have a better idea of just how huge and important this field is, let's do a little myth busting. It's time to tackle some of the stereotypes that people still have about it.
Myth number 1. It's just a desk job, right? You're stuck in a cubicle all day. Nope, not even close. Sure, the design work happens in an office, but a huge part of the job is getting your hands dirty. You're out in the field installing systems, you're on-site testing new equipment, you're troubleshooting real-world problems. It's this awesome mix of thinking and doing.
Okay, and this one is probably the biggest myth of all, that it's just connecting cables. Let me be super clear here. Connecting the cable, that's maybe 1% of the work. The other 99% is all the brain power that came before it. The circuit design, the signal processing, the power calculations, figuring out the entire system's architecture. That one cable is just the very last tiny piece of a gigantic engineering puzzle.
And the last myth, that jobs are hard to find. This could not be more wrong. The reality is, demand is absolutely exploding. I mean, think about it. The world is moving towards more automation, more AI, and a huge shift to renewable energy like solar and wind. What do all three of those things need? You guessed it, more electrical and electronics engineers than we've ever needed before.
So, if there's one thing to take away from all this, it's this. EEE isn't just another job. It's the invisible infrastructure of our entire world. From the phone in your pocket to the factory down the road, from AI to clean energy, it's all built on a foundation laid by these engineers.
And that brings me to a final question, just for you. After seeing just a tiny slice of what's possible, if you were one of these engineers, where would you want to make your mark? Would you jump into automation? Or maybe push the limits of AI hardware? How about building the green energy grid of the future? Or would you rather design the next generation of life-saving medical devices? It's a lot to think about, right? Because the future in every single one of those fields, well, it's still waiting to be built.